Hi again. In this section for the strategy of computing limit, I want to explain number 11 till 16. The number 11 say that when we have the limit of 1 plus 1 over n exponent to n, when n approach to infinity is equal to e. And 12 is the consequence of 11 when we have a limit of 1 plus m over n power n when n approach to infinity is equal to a power m. Suppose that I have this limit. Sometimes you see this example which is not in the form of 1 plus 1 over n. And I suppose that you don't also know 12 and just you want in terms of 11 solve any question. So if for this limit, now you see this is not form of 1 because 2 is not appropriate, and also we have x plus 2, here is x or n. Here also, so let's do some change. We can write here limit of 1 plus 2 can come in the denominator of x plus 2, so I can write x plus 2 over 2, and here I have x times 1 over 3. I want to change to get x plus 2 over 2 because this should be n. So right, and I will add 2 and decline 2 over 2 when x approach to infinity. This will be equal to, now I can separate this one and I will write as the limit of 1 plus 1 over x plus 2 over 2, and here x plus 2 over 2 minus 2 over 2, which is 1, and both of them is multiply in 1 over 3 when x approach to infinity. So if I suppose that x plus 2 over 2 is y, when x approach to infinity, y also will approach to infinity. So I just change, I will write 1 plus 1 over y power y. Now I can write here as separate minus 1. So here minus 1, I can bring this one in denominator. So this one time multiply in 1 over 3. So it means that all of these power 1 over 3. When y approaches to infinity, so limit of 1 plus 1 over y, this one is e, and this one when y approach to infinity will be 0. So 1 plus 0 is 1. So here I have e over 1 power 1 over 3, which gives 1 e power 1 over 3. Another example here is when we have limits of 1 plus 3 over x minus 2 power x when x approach to infinity. To solve this, as you see, we have to convert to the form of 1 plus 1 over y or power y when y approach to infinity. So here we have to do some change over these parts. We can write limit 1 plus, here should be 1, and I have to bring 3 in denominator, and here x when x approach to infinity. So if I suppose that is y as x approaches to infinity, so y also approaches to infinity. So I suppose that is y, and I have to change to y. So I have to write minus 2 because I want to get this form, and I add 2 again over 3. I divide by 3 and multiply by 3. Write limit of 1 plus 1 over x minus 2 over 3 power. I divide this part because I need this x minus 2 over 3 plus 2 over 3. This one all time 3. When x approaches to infinity. Now I will change x minus 2 over 3 as y. So when x approaches to infinity, y will be also approached to infinity. So again I can write limit of 1 plus 1 over y plus 2 over 3. I can write, separate this one, letters I can write this power 3, divide this 2 over 3, and I will have limit of 1 plus 1 over y, and multiply in 1 plus 1 over y, and also as limit is can come inside because it's continuous, so I can write this part power 3 when y approaches to infinity. So we will have this limit times this limit, because according to the theorem, so limit of this one when y approach to infinity will be e, and this one over infinity is 0, so we will have 1 power 3, so we will get e exponent to 3. Another example here is limit of radical 3x 4 minus 2x 3 plus 1 when x approaching to infinity. According to 14, we have the even, if n be even number, so radical of axn plus bxn minus 1 is equivalent to positive and negative radical n times x plus b over n a. And for odd number we have just this without positive and negative, just we have radical na times x plus b over na. So if we go back to this, we can say that this is equivalent to limit, as 4 is even number, so we can say positive and negative radical 4 3x, because 4 over 4 is 1, minus 2 over 3 times 4. So when x approach to positive infinity, will be time in positive and negative radicals, so we will get positive and negative infinity. And another example, this limit with when 3 is an odd number, so this is equivalent to just radical 3 minus 1 times x plus 5 over 3 times minus 1. So we can get this limit when x approach to negative infinity will be equal to, and this one is minus, and x times this minus, we have the limit of minus x minus 5 over 3 when x approaching negative infinity. This is negative infinity times this negative, so we will get positive infinity. Number 16 is a squeeze or sandwich theorem, and it says that if we have a function f which be a squeeze between two functions g and h, we can say that if the limit of g and h have the same value of l near to the point A, so we can get the result that f also have the same value limit L. So let's come back to this example. We have limit of x2 plus 5x times 3 over x when x approach to 0. Now we have to squeeze the f between two functions g and h. So I have to find g and h. As you see in this formula, we can say that sine 3 over x always between maximum and minimum range is minus 1 and 1 change. So we can say that sine 3 over x between minus 1 and 1 change. So here if I want to figure out f, so I have to multiply in x2 plus 5x. So I multiply both sides in x2 plus 5x, so we can get this, and now we can get the limit from both sides. When x approach to 0, so limit of x2 plus 5x will be 0, and also x2 plus 5x uh, in upper bound is 0. So we can find now for the limit of x2 plus 5x sine 3 over x, as is squared between g and h have the same value limit of 0, so the limit of f also equal to 0. Another example here, limit of x time this term when x approach to 0 from right side. And now if I suppose that is f, I have to find again g and h which have same value near to 0 from right side. So I can estimate this part, integer part of 1 over x, 2 over x till 100 over x. According to the formula for integer part, I can say that for any integer y, always y between integer part of y between y minus 1 and y plus 1 changes. Sorry, integer part of y changes between y minus 1 and y plus 1. Now I use this fact in the term of 1 over x. I can say that 1 over x integer part between 1 over x minus 1 and 1 over x minus plus 1. And also for integer part of 2 over x, again have same fact till 100 over x integer part which change between these two terms. Now if I want to figure out that f, I have to sum all of these. After summing, I can get this result that this term between 1 over x plus 2 over x, 100 over x, which I can add as 1 ratio minus, and 101 we have, so summation will be 100. Less than, again, 1 plus 2 plus 100 over x plus 100. I can now multiply in x to figure out the f, so after we can get the limit. According to this fact, f1 plus 2 plus n will be equal to n times n plus 1 over 2. I can use this fact to calculate the summation of 1 plus 2 till 100. So this will be equal 100 times 100 plus 1 over 2 over x minus 100, and also for upper bound will be less than 100 times 100, 1 over 2 over x plus 100. So this term will be equal to 100. 100 plus 1 over 2 is 50, 50 over x minus 100, and also for upper bound same. And now we can get the limit from both sides. So this limits After multiplying in x, we can get when x approach to 0 from right side is equal to 50-50. So f is sandwiched between 50-50. According to the sandwich theorem, we can reach to this, that limit of f also near to 0 from right side is equal to 50-50. The last end of this topic, I want to explain one important note which may you face in different questions when you want to compute limit of function, and you have to pay attention to this notation that this is you can consider when a is a natural number or any number more than 1 and b be positive number. So always x power x is in comparison has the strongest value, and then is x factorial, and after that the exponential function ax, and then x square, and ln x is specified the least in measure in comparison to other functions. And also if a more than b, we can say that a power x always more than b power x, and a and b both be bigger than 1. For example, I consider limit of 3x power 3 plus 3x over 2x plus x5. When x approach to infinity, if you want to get a limit, you will see here that in computing limit infinity, we consider x with the biggest or with the largest degree or with the strangest power. So if you comparison x3 and 3x, so x exponential is stronger, so I will consider between 2 3x. And if I want to comparison 2x and x5, also 2 power x is stronger, so I consider 2 power x. Now I have to comparison denominator and numerator. As you see also here, we have 3 and 2 with power x. As you know, 3 more than 2, and according to power x more than bx when a more than b. So here we we conclude that this limit as 3 power x is more than 2x, so approach to positive infinity when x approach to infinity. Or another example, x factorial plus xn over nx when x approach to infinity. If you want comparison x factorial and xn according to this notation, you see that x factorial more than xb. So here x factorial is bigger than this one. If I want to write, let I write here, I can say that this is equal to limit of, so between x factorial and xn, x factorial is stronger over nx, so x factorial is in the second strength in power, so x factorial is more than nx equal to infinity. And for this example, you see that limit of ln x plus x factorial over x power e is equal to, if I want to compare ln x and x factorial, again x factorial here is more than ln x, so I consider ln x, or even I can separate together ln x over xx plus x factorial over xx, so I get separate limit for both according to the theory of summation of limits. So here ln x over x power x, as you see x power x is more than ln x, so this approach to 0, and also x power x is stronger than x factorial in comparison these together, so will this also approach to 0, so we will get 0 plus 0 is equal to 0. Or another example, limit of x plus x power x plus ln x over x factorial. If I separate two limits and numerator will be separate as x power x over x factorial plus ln x over x factorial. So here you see that x power x are stronger than x factorial. So this approach to infinity, this x factorial is more than ln x. So this approach to 0 because more infinity we have in denominator, and so this approach to 0. Infinity plus 0 is equal to infinity. At the end of the series video be titled The Strategy of Computing Limits, I hope these small steps be helpful for all of you, and I wish the best from God for you in your study and in your life as well. At the end, I want to pray to all of you, be all of the universe and all of the students be healed from negative energies and illnesses. Thank you. Please subscribe to my channel. We always in shadow of God. Thank you and bye.